Okay, so for number 6, there's going to be one of these on your test where you have to know what do we set that equation equal to when it's a 12-sided polygon. And so we need to remember that little tiny formula. So if you recall, we did a whole bunch of shapes of a polygon. We did a triangle, 4-sided quadrilateral, 5-sided pentagon, and then, oh, that's a 6-sided. And then we drew triangles inside, and we said how many triangles are in there. So in a triangle, there was just one triangle, 180. Inside of a quadrilateral was 180 twice. Inside of a pentagon, oh, this is actually a hexagon, we could draw 180, 180, 180, 180. So we started to notice that pattern where it was always going to be 180 times the number of sides minus 2. And so for a 3-sided figure, a triangle, 3 minus 2 was just 180 times 1. For a 4-sided figure, it was 4 minus 2 is 2, etc. So we came to this agreement that this would be the little formula, 180 times the number of sides minus 2. So a 12-sided figure, we now go plug in 12. And 12 minus 2 is 10. So 180 times 10 turns into 1800. So find the sum of the measures of a 12-sided polygon, that's 1800. If on the final exam, we give you a picture of a 12-sided polygon, and then inside here is all these different numbers, you add all those up and make it equal to 1800. Does that make sense? So make sure you've seen at least one of those, practiced at least one of those before your final, and you remember how to get what it's equal to with this little formula. All right, number 7, find all the variables. We're first going to, by knowing the triangle sum theorem, tells us that triangles add up to 180. We're going to be able to say x plus 24.6 plus 90 equals 180. Grab a calculator. So that's just the angle to start with. Now we're going to use trig to do these other two sides. So using a reference angle at 24.6, I can first solve for y by doing opposite over adjacent. And then I can do the other one with the sine function. Opposite over hypotenuse. That's a z. So this is going to be the divide one, where I do 16 divided by the tan, and I do 16 divided by the sine. So we get 34.95 rounded and 38.44. So 34.95. Now this is units because it doesn't say feet or anything else. And then the second one, 38.44. Okay, so to find a side, we used trig. Now it says a pole casts a 10-foot shadow. Sally is 5 feet tall and casts a 2-foot shadow. How tall is the pole? Sally is 5 feet tall and casts a 2-foot shadow. How tall is the pole? So what we have going on here are two similar triangles, and we're saying 2 is to 10 as, and Sally over here is 5. 5 is to what? So the smaller triangle to the longer bottom, and then the smaller height of Sally to the longer pole. That's our unknown, this big old X. So we say 2x equals 50. Height of the pole is 25 feet. So that's a word problem using similar triangles. Given that lines A and B are parallel, prove that angle 2 is equal to angle 7. So angle 2 and 3 are equal because vertical angles are equal. Angles 3 and 6 are equal because alternate interior angles are equal. Angles 6 and 7 are equal because vertical angles are equal. 2 and 6 because corresponding angles are equal. And then finally 2 and 7. 2 and 7. So if 2 and 3 are equal, and 2, basically we're using transitivity here. Because if 2 and 3 are equal, and 3 and 6 are equal, and 6 or 7 are equal, then 2 and 7 have to be equal. So it's like moving down the line. If this and this are equal, and this are equal, and this is equal to this, then the original is equal to the final. And that's called the transitive property. But what was this activity about? Like, why did they have you look at this picture? They wanted you to be able to recognize all these little rules that might come up on your test. All right, factoring a polynomial with a greatest common factor. Do you see it? A -5 can come out, and an x can come out of everything. So if a -5 divides out of the front, we're left with x squared. In the middle, do you see that negative divided by negative is going to give me positive, and then there's 1x left over. 10 divided by -5 leaves me -2. Now you do want to always check the back to see if there's anything that multiplies to give you this or add up to 5, and there isn't. So this is now fully factored just from greatest common factor. This is called Gcf Factoring. All right, for this one, the product of multiplying a binomial times a trinomial, you could use FOIL or the box. The last one I showed FOIL, so this time I'll show you the box. So now just fill in the box. 5 times 3 is 15. X times x squared is x to the third. 5 times 4 is 20. X times x is x squared, negative 10x. 3 times 6 is 18. 6 times 4 is 24. Don't forget the x. And negative 2 times 6 is negative 12. Now you go down these diagonals and see if there's anything that can be combined as far as a like term. And the x squareds can go with the x squareds, the x's can go with the x's, but everything else will just be by itself. So 15x to the third plus 38x squared plus 14x minus 12. This 38x squared came from adding 18 plus 20 x squareds, and this 14 came from 24 minus 10. Does that make sense?